Okay, so this is the solution to number 4 of our second practice test. And so reading the directions, the important facts are, we have a differentiable function f. The domain is all positive real numbers. That's essential, positive. And we are given the first derivative. So in part A, we have to find the x-coordinate of a critical point. Well, we know that critical points occur when the derivative equals 0 or when it's undefined, or also at endpoints. But notice it's greater than 0, so there are no endpoints. So looking at this first derivative function, if I write it as a rational expression, then it will be a little bit easier to decide where the critical points are, because this derivative equals 0 when the numerator equals 0. So that would be when x is equal to 4. Now this derivative will be undefined when the denominator equals 0. That would be when x equals 0. Now because x must be greater than 0, this is not going to be a valid critical point. So now let's look at this critical point and let's create an f prime sign chart. And if I choose a number less than 4 and substitute it into the first derivative, let's say 4 minus 3 is 1, so that would give me a positive derivative. If I choose a number greater than 4, like 5, 4 minus 5 is negative. So that would give me a negative derivative. So therefore 4 is a maximum because it's changing from positive to negative. Now I must write my one sentence justifying this. So at x equals 4, there is a relative maximum. Okay. Since f prime of x changes direction at this point from positive, or changes sign, we should say changes sign at this point from a positive to a negative. There, we have just thoroughly answered question A. Okay, now let's go on to question B. So question B says that we have to find all the intervals on the graph of f that's concave down. Now when I think of concave down, immediately we should think of second derivative. So I have to find the second derivative when I'm given the first derivative. Okay, no problem there. So part B. So the first derivative is, now I have a choice. I could use the quotient rule, 4 minus x over x to the third, or I could use the product rule, first term times the derivative of the second, or I could use the power rule, because if I distribute the x to the negative third, I would get 4x to the negative third minus, and this is x to the 1, minus x when I add them to the negative 2. So then the second derivative is when you take the derivative of a power, you bring the power forward, negative 12, and subtract 1. Make sure you subtract 1. And then you bring the power forward, so it would be plus 2, subtract 1 is negative 1. Now let's simplify so that we can look at critical points. So if we write it as a rational expression, it'll be much easier than to look at when the numerator and denominator is equal to 0. So, oh wait, I made a mistake. Right here, negative 2, I'm supposed to subtract 1. Negative 2 minus 1 is negative 3. Wow, that was almost a huge mistake there. Okay, common denominator would be x to the fourth. So it would be negative 12 plus 2x. So that is the second derivative. Now, to find out where critical point happens is when the derivative equals 0. So negative 12 plus 2x is equal to 0. So then 2x equals 12. So then at 6. Now, I don't have to consider when the denominator equals 0, because it would be 0, and 0 is not in at the values for the domain, because x has to be greater than 0. So now looking at a second derivative sign chart, let's see what happens with the concavity. So if I pick a number less than 6, like 5, and substitute it into the second derivative, negative 12 plus 10 is a negative, so it'd be negative. Pick a number greater than 6, like 7, negative 12 plus 14 is positive. So therefore, this graph is concave down when the second derivative is negative. So then we can say on the interval from 6 to 0, the graph is concave down because the second derivative is less than 0. It is concave down. I'm running out of space here. Since f double prime of x is less than 0. There we go, great. Now that was part B. Now let's move on to part C. Now part C, we are given a value for f, and we are told that if f of 1 is 2, we have to find the function f. Now again, there's a variety of ways to do this problem, but I know that I am given the derivative, and from the derivative, I need to find the f function. So in other words, I need to go backwards. Well, we call that an antiderivative, right? So f prime of x is 4 minus x times x to the negative third. So if I'm take the antiderivative of this function, and I'm going to go from 1 to a value x, but since, actually, if I go to x, then I have just to change these variables from x to like t, okay? So let me just make this grammatically correct here. So 4 minus t times t to the negative 3, and its derivative in respect to t. So now let's take the, and this would be equal then to f of x minus f of 1. Fundamental theorem right there. Okay, now I'm going to use the power rule again here. So let's distribute. So I get 4t to the negative 3 minus add t to the negative 2. Okay, now when I take the antiderivative, instead of subtracting 1, I'm going to add 1. So t to the negative 3 plus 1 is negative 2 divided by the new exponent. And then add 1 to negative 2, so I get negative 1 divided by the new exponent. And we're going to evaluate that from x to 1, and that will equal f of x, and we know f of 1 is 2. So I get negative 2x to the negative 2, and it's going to be plus x to the negative 1. Whoops, why did I write 2? X to the negative 1. Can you read that? And now I'm going to evaluate it in terms of 1. So I get 4 times 1 to the negative 2 all over negative 2 minus 1 to the negative 1 all over negative 1. And that will equal f of x minus 2. Okay, now I need more space. How do I get more space? Let's see, I guess I have to erase some work. Sorry about that. Okay, so if I erase this work up here, so I can give myself more space. I wish I had a bigger whiteboard. Okay, so now I'm going to, whoops, go back to pen mode. So now if I go back up to here, so I still have negative 2, x to the negative 2, and then it's plus x to the negative 1. Now let's do my mathematics very carefully here, minus. So it would be 4 over negative 2, which is negative 2, and then it'd be plus 1 is equal to f of x minus 2. So it's negative 2, x to the negative 2 plus x to the negative 1, and negative 2 plus 1 is negative 1 minus, so it's plus 1. Shoo! And then I add 2 to both sides. So the function is, here we go, folks, add to the negative 1, add 2, 3. There we go. Nice work. The end.